Hello, this is Diganto, and welcome to the complete SAT Math Review course, Heart of Algebra section, brought to you by Googolplex Academy. Building on the linear equations that we discussed beforehand, linear inequalities are another topic that could appear on the Heart of Algebra section of the exam. Like equations, linear inequalities are mathematical statements that relate to expressions. Rather than showing equality, though, they're used to show that an expression is less or greater than another expression. They can also show that something is less than or equal to or greater than or equal to something else. Similar to equations, a solution of an inequality, when substituted in for the variable, will produce a true mathematical statement. For example, 2 is a solution to this inequality. If we substitute 2 for the variable and simplify, we get a correct mathematical statement. We also get a true mathematical statement if we use 4 as our solution here. So how exactly do we go about finding these solutions? Let's solve the following inequality to find out. These steps for solving are actually quite similar to solving a linear equation. As our first step, let's simplify what we can on either side using the order of operations. Next, we should start isolating the variable using the reverse order of operations. Check out our video on equations if you want a quick review on how to simplify and isolate variables. With inequalities, however, there is a little bit of a trick here, so let's slow down and be careful. We can start by subtracting 4 on both sides. Afterwards, if we try and divide both sides by -2 in order to get x by itself on the left side of the inequality, we end up with the statement x is less than or equal to -3. This is dead wrong. Really though, pause the video and substitute values less than -3 into the inequality. You will get a wrong answer for anything that isn't exactly -3. So what went wrong? You see, whenever we multiply or divide by a negative number when isolating the variable in the inequality, we have to reverse the inequality sign, no matter which inequality sign that we're working with. That is the main difference between working with these inequalities compared to equations. Multiplication or division with a negative number means we reverse the inequality sign. Remember that. So, when we divide both sides by -2 and reverse the inequality sign, we get the statement x is greater than or equal to -3, which means any value greater than or equal to -3 is a solution to the inequality. As one final note, we can show our range of values like this, but our answer could also be represented by specifying that x can be between infinity and -3. Note that we use the greater than sign instead of the greater than or equal to sign, since x can never truly equal infinity. That's just not a real number that a variable can equal. While these ranges of solutions for inequalities can also be represented with something called interval notation, you can click on the iCard in the upper right-hand corner for a very quick review of that. Otherwise, go down to the description to download a couple of practice problems, and when you're done, click on the link within the document to see those problems worked out. Email us at googolplexsatacademy@gmail.com and check out our other videos and subscribe for more SAT prep. See ya!